Hey, it's Chuck. I'm back again with my space station rebuild here. Today we're going to work on some soldering and desoldering skills on our auxiliary driver board. I'm going to pull off that relay that's on there that needs to be replaced. I've got a bridge rectifier we can swap out. Plus, we're going to look at some new parts that I got for this machine. And then finally, I'm going to show off a new pinball machine that I picked up that's going to be my next project. Let's take a look. You probably remember from last time I talked a little bit about this relay here. Was the problem causing my coils not to fire, and I took it apart and cleaned the contacts and it works, but I still need to replace it. So we're going to pull this board out. So I'll need to pull out my score panel here. Let's see if I can get that. There we go. And this board right here, we're going to pull it out. We're going to replace this relay, and I have a bridge rectifier that was replaced with one that has the wrong kind of connectors on it. So they just attached it by some wires, it's just hanging loose. So I bought a bridge rectifier with the wire type connectors on the back, and I'm going to solder it right to the board. So let's get started. As you can see, I've got the auxiliary driver board out of the machine. We're going to be replacing this relay right here, as well as this bridge rectifier. To do so, I need to desolder these parts, and I find the best tool to do that is my Heiko 808 desoldering iron. So let's get started. So let's take off this old bridge rectifier first. Let me show you first why I'm replacing it. If I peel off this tape here, you can see that the rectifier has spade lug type connectors on it, and somebody has just soldered wires, jumper wires onto those spade lugs, and then put those into the circuit board because those spade lugs will not fit into the little holes on the board. And this is fine, it works, but I just, in the interest of tidying this up, I'm going to replace it with this one that has the proper wire style connectors. So we're going to go ahead and unsolder this. You can get rid of this tape off my hand here. And I'm going to use my desoldering gun. And how this works is I press it against the wire that's coming through the back of the board, and I move it around a little bit and then hit the vacuum trigger, and it sucks away all of the solder. So let's just do the rest of these really quick. And there we go. And I realized I just desoldered one of the legs of the other rectifier here accidentally, so I'll have to resolder that. So if I turn it over, we should be able to pull this out. And if we can't, there's still some solder left on the other side. There's two of the wires. The other two are stuck. I'm going to use my regular soldering iron here and soften those up a little bit. There's one. And there's the other. And so we got it out. Okay, now I inserted our bridge rectifier, but I haven't soldered it in yet. What I wanted to show you is that it's important that you leave some room for airflow underneath this bridge rectifier. These do get very hot because of the amount of current that flows through them. So if you leave them off the board like this, you can see that the other bridge rectifier also has, I don't know if you can see that, also has some space underneath it. That'll leave room for airflow and cooling. So let's go ahead and solder it back in. Okay, next up is to replace this 24-volt relay here. So this relay is soldered to the board with 8 lugs that are through-hole lugs that go through the board, and they're actually quite large. because they carry a lot of current and because this is a big component to be soldered onto the board. And unfortunately, they're too large for my desoldering iron to fit over, and I have the largest tip on here. I've shopped around to see if I can find a larger tip, but I can't actually get it over these. So what I have to do is put my desoldering iron next to the lug, press it against the lug and the pad, and get it as softened up as I can, turn that solder into liquid, and then hit the vacuum. Alright, so I've got this relay off, but there is a problem. And the problem is that this relay has been replaced before, and these solder pads on both sides of the board are really beat. And so what happened is there's a through-hole piece of metal that lines each of these holes here that connects the top and the bottom pad together through the hole. And I pulled a few of them out. When I pulled out this relay, they're actually connected to the pins here. What I'm going to have to do is use some wire wrapping wire and solder it to the top trace here, and then put it through the hole and then solder it to the pad on the other side to replace the through-hole metal that got torn off with this relay. I don't know if you can see it, but what I did is I took a little piece of braided wire, like wire wrapping wire, or wire a little thicker than that, and I put it through these holes. These four, here, 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 and here, are the ones that are most important because they actually have traces on this side of the board that would be underneath the relay once it's installed. So in order to make sure that the relay legs are making contact with these traces here, 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 and here, I have to run this wire through the hole. I soldered it to the trace on the top. I scraped some of the solder mask off. Sorry, I can't see it very well there. Scraped some of the solder mask off here and here and here and here, and I soldered the wires on, passed them through the holes. And if you flip it over, you can see where the wires come out on the other side. So I'll just drop this relay back, line it up with the holes here, and drop it into the board. Alright, we got our board back in place and all connected up. I turned the game on, and it came on, which tells us, and went into a track mode, which tells us that that bridge rectifier is working. If that wasn't working, we would definitely not be booting up into a track mode. The other thing we need to check is that this relay is functional, and the best way to do that is to drop some balls into the drain here, and if they activate the switch and they are fired into the ball trough, the only way for that to happen is for that relay to operate. So drop the ball in. So let me put the rest of the screws in it, and we'll call that job done. So I'm going to demonstrate quickly how these optical sensors work for the ball diverter. I'll pull this board out, and you can see that there are two of them, and they're sort of U-shaped. One side transmits infrared light, the other side receives the light, and if the light is seen by the receiver, it's considered to be on in this application. So because both of these are unblocked, you can see that we're seeing space station switches 1 and 2 are both tripped. I'm going to go down here and insert a screwdriver into, sorry, see if I can show this, it's kind of hard to do with only two hands. So I've inserted a screwdriver between the switch 2 optos, and you'll see that right now only switch 1 is activated. So that proves that switch 2 is functional. So this opto switch 1, I'm going to insert a screwdriver blade into that one like this. And we're going to go up and see that neither of the space station switches are live right now. And then while I'm showing you the switch readout here, I'm going to pull out this screwdriver and see what happens. There it is, switch 1 activated. So these switches work, no need to replace them. So I do need to replace the motor because it is the part we identified as the failure point. So let me show you that. So this is the motor that powers the ball diverter. It's a small 11 RPM motor. The motor's inside this large cylinder, and there's a gearing inside here that turns this shaft. And it's an AC motor, and that's important to know, and I'll explain why in a moment. But it's obvious that somebody serviced this before. The little crimped edges here that hold this plate on were bent loose, and this plate was loose. So I'm going to pull it apart, and we're going to take a look inside. Here's the inside of our ball diverter motor. And pretty simple mechanism. There's on the end of the shaft is a gear, and that connects to all this gearing, and then there's a drive gear right here which the motor spins. And because it's an AC motor, it can start in either direction, so this mechanism is designed to force it to only spin in one direction. And that mechanism has worn a groove into the drive gear, and so it jams up. It just won't spin because when it spins in one direction it jams, and the other direction it jams. It's just I would need to replace these gears that are worn out in order to make this motor work, and there's no point in doing that because I can simply order a new motor from Marco, which I did for about 60 bucks, and then I'll have a new highly functional motor. Don't have to worry about this thing failing anymore. So all I need to do is take my motor out of the bag, and you can see it just has 2 wires coming out. So I'll remove the connector from this motor, which it's pretty obvious here that it's been replaced before by these wire nuts. But I will remove this connector, connect it to the new motor, and we'll get it installed. Got the opto board screwed back in here, so we're going to reassemble this diverter and test it out. Just going to sort of dry fit it together. One thing I should point out is at the base of this motor shaft is a pin that I forgot that I needed to insert. So it goes into one side and it rides in this groove here that spins this bottom part of the ball diverter. So that pin has to be in there or that shaft will just spin inside this piece here. So again, you can see the ridge that's going to ride inside the optos here. So we'll drop this in. We have to align the groove with the pin. So we'll do that, and I've got it in there, so it's locked in place by that pin right now. And then we're going to drop our ball diverter on. And you see the ball diverter has a recessed area that fits onto this piece here, so they only fit together one way. So let's go ahead and put it in there. There, it's okay, it's snapped in place. Got the ramp inserted back in, just enough for us to test this out. And got the machine in the track mode, so let me start a game. I don't know if you saw that, but the diverter spun into place. It was prepared for the first ball to come up the ramp and go down into this ball lock over here. First ball has come into the shooter lane, so we're going to grab it. We're going to activate the drop target in front of the ramp.
Those doors are open.
And our ball would go up this ramp through the ball diverter. Lock. That's the rotate. There it goes. Perfect. It just rotated to take the ball into the second ball lock. Our second ball's in the shooter lane. We're going to grab that. And we'll activate. We don't have to put our drop target down, but we'll go up the ramp. Side. Now we have both balls locked. Third ball's in the shooter lane. Let's grab that. To release, we can get it into either one of the vertical up kickers. I'll see if I can get it into this one.
Docking complete. Negative, you must redock.
So as you can see, the ball diverter was triggered to spin at the right time. And it spun and positioned itself in the correct place based on where the opto sensor told it to go. So I'd say we're ready to go here. We just need to properly reassemble this. I still have some playfield work to do. This ramp is being replaced, which I'm actually going to show you the replacement ramp in a minute. So I'm going to, for now, just call this done, but we do have more work to do on the playfield. This is the ramp that leads up to the ball diverter for locking balls in Space Station. And the ramp on mine is pretty beat. Normally there would be a transitional piece here that has broken off. You can see how the end of the ramp is just completely blown out on this side. This side was blown out and then repaired with a piece of plastic, but it's starting to blow out again. This side really gets it the worst when the ball hits it. And then the top of the ramp doesn't look too bad, but the switch is all out of adjustment, which could be fixed. But you can see where the ball hits this metal piece here and then falls straight down, and it's just blown this all out, which is not terrible. The game still works, but it just looks pretty bad. Anyways, on pin side, I found a guy who remanufactures these ramps, but he makes them out of blue plastic, and I ordered one. But, so this is a replacement ramp, and this thing is amazing. It is made of thicker plastic. This is like an ABS plastic. I'm not sure what this is, but it's a heavier gauge of plastic. I believe this guy makes them himself. He vacuum molds them. But you can see here, the end of the ramp, the really bad spot has been reinforced with a piece of gunmetal riveted in place. You've got the gunmetal ramp transition here riveted in place. So right where your ball really takes its biggest hole in the ramp, this has all been reinforced. It matches the ramp, the original ramp, one for one, everywhere. You get your same cutout here as you have here. All the holes were drilled already. So that hole matches that hole. And everything's all ready to go and drop in. And I've bought reproduction ramps before, and I've never gotten one that actually had all of the hardware already in place. You can see this switch is riveted on, and you've got the protective piece of metal riveted on here. And every other ramp I bought, I've had to cut these rivets off and take these pieces off of the old ramp and rivet them onto the new ramp. But this came 100% pre-assembled. This is a piece of aluminum angle iron here, angled aluminum, I suppose you'd say, riveted in place, holding a micro switch instead of the leaf switch on the old one, so you got much more reliability there. It's pre-wired with all the same exact connector, ready to drop in. And then this is kind of cool. You can see here they just cut out the end of the ramp for the ball to drop through, but this fellow has actually attached a clear kind of lucite cylinder or ring for the ball to drop through, which is really kind of a tough material here. So you've got your metal protector already installed, came with the ramp, and then this reinforced hole here to keep it from breaking out like the other one did. So really an amazing thing. It was a little spendy, but I think it was worth it. One of the things I like about it is how it's blue, so it will match the upper playfield translucent blue here. It won't match the ball diverter, which is fine, but because it's transparent, you can do some interesting tricks with light shining through it. And one of the ideas I saw on Pinside is somebody found these lights on Amazon, and they're sold as like Knight Rider LED lights, like you'd put them on your car and it would create a sort of Knight Rider effect. Let's see if I can get one out of the front of kit from Knight Rider, where the lights pulse back and forth. Well, the problem is it actually only goes in one direction and then starts over. It doesn't go back and forth like Knight Rider. But that's actually perfect for this ramp. And the idea is you install these lights behind the plastic along this inside wall of this ramp. And then when the drop target goes down and the ramp is activated, then these lights would come on from behind the plastic. And they would show you that the ramp was active and that you should shoot there. And they're blue LEDs, so they match the other blue lights in the blue plastic of the game. So I'm going to give that a shot. I bought 2 of these. I'm going to try them on both sides of the ramp. The video I saw where somebody had done it looked amazing, so stay tuned for that. All right, finally, here's one more thing I want to show you before I sign off. In my garage here, I have all the pins that are on my workbench, pins that I'm going to be working on at some point in the future. And I've had these 2 for a while. This one, can't really tell, is Chicago Coin Casino. It's an electromechanical machine. The next one over here is Mars Trek by Sonic, which is also an electromechanical machine. Both of those work, but they need to be restored. I'm working on that. But this is what I really wanted to show off, and I just got this guy a couple days ago. It's Gottlieb Black Hole. It's a machine I've wanted for a long time. This one works, but as always, needs a lot of work to bring it up to the standards that I like. So look forward to some videos on the Black Hole.